Alright, I had promised a video sort of tying together empirical formula to get to molecular formula using baseball. So again, this is a problem where we start with some information about the empirical formula, or gets us to empirical formula, and then we use that to get to molecular formula. So the title of this should be, again, using empirical formula. So I'm just abbreviating empirical formula to get molecular formula. Empirical formula to molecular formula. How we can do those types of problems. Now, I've put it into a baseball sort of frame. We're going to have 4 steps to get from home all the way around to get us from empirical formula to molecular formula. Now, we're going to actually land on third base will be the determination of the empirical formula that's sort of hidden in these starting weights. My blue is going to be phosphorus. That's our first pitch. It's going to be phosphorus, and our second pitch is going to be oxygen, and it's a certain amount of weights of each. So phosphorus 4.433, sorry, 5.717 grams for oxygen. Now here's the first thing you must do then for these types of problems. I'll put it in black here. It's our first step. We must divide the masses, each mass, so I'll just say weight, by respective molar mass. My black is dying, so I might have to switch to green. So to get to first base, we have to divide each of these by their respective molar masses. Now if you look up phosphorus, phosphorus has a weight of 30.97. So the first thing we do is divide this number by 30.97. If you do that, I'm going to put it in blue, you get 0.1431. That's phosphorus if we divide this mass by its molar mass, by phosphorus molar mass, which is, again, 30.97, and you find that on the periodic table for phosphorus. What do we do with oxygen? The same thing. This is the weight we were pitched. This is the weight that was thrown at us. 5.717 divided by oxygen's molar mass. From the periodic table, we know that's 16, and that would give us a number of, I'm going to put it here, 0.3573. Now this is moles, so we're going to write this as moles. And you use MOL. Now the second move we make to second base involves a different rule. I'm going to put it in green just because my black marker is dying. The second, all these markers, lay them right here. The second rule is, again, different. It's going to take these numbers that we just found and divide each of these numbers by the smallest of the two. Smallest of the two. So which one of these is smaller? Hope you're saying the 0.1431 is smaller. We're going to divide then that by itself and divide this one by 0.1431. If you do that, of course in blue, we're going to put this right near second base. You'd have a 1 as a value, because 0.1431 divided by itself would be 1. And then this one here is going to give us 2.497. So pretty close to 2.5. That's going to be important here as we move from second base to third base. Going to third base, here's our third rule. Double these numbers. And you say, well, what do you mean these numbers? These here that we're starting from for second base, till you reach whole numbers. Say it again, you're going to double these until you reach whole numbers. I notice right now 1 is a whole number, but this is not. But if I double 2.497, I'm really close to 5. So I'm going to go ahead and double the first one. That gets us to 2. 1 doubling that gets us to 2. But doubling 2.497 gets us really close to 5. Now I need to stop here, and we did this in class, kind of a thought box. What this really means, these numbers, is that we've just found the empirical formula for this phosphorus and oxygen that was thrown at us originally by weights. We just knew that some molecule or something made by putting these two together had this much weight for phosphorus and this much weight for oxygen. We know now not how many are in the molecule, but the smallest whole number ratio we now know. It would be P2, you can guess it, O, hope you can guess, 5. Now the last step is to take what is now the empirical formula. I'm going to label this. This is empirical formula, P2O5. And if we want to move from empirical formula to molecular formula, well, we have to be given as a given amount, something given to us, is we have to, I'm going to put it inside the, I guess, diamond. We have to have something given in this type of move. We have to have the mass of whatever was thrown at us, the over total mass. We have to be given that for the molecule, what was given to us. I'm just going to end it this way. If they give us not just these starting pitches, but what was the total molecular or molar mass, what we do is just divide that by the mass of P2O5. So again, this move from third base to fourth base, what you have to do is you have to be given two things. One, we need to know what the mass of the molecule is that you're trying to put together. That's the first thing. The second thing we already found, the empirical mass. So what you do is divide, in this last step, the molecular mass by empirical mass. The mass for this is divided into the molecular mass. We'll do one of these types of problems in class to finish off this last step. Make sure you can get at least to third base to find what? The empirical formula, which if we then add up 2 P's and 5 oxygens would be the empirical mass. How would we get from third to fifth? We would just take whatever mass they give us for the molecule and divide it by the mass for this. Thanks. Bye-bye.